Hello, Mr. Holmes again. Right, this is a video continuing on from my previous video about what character sets were and what the standard ASCII character set is. So in this video, we're going to start by looking at what is the standard ASCII character set all about. Well, you recall in the previous video, we talked about the standard ASCII character set, which uses only 7 bits to represent up to 128. Why? Because 2 to the power 7 is 128. Up to 128 standardized characters representing most of the letters of the English alphabet, various control characters, and a selection of punctuation symbols and some basic mathematical symbols like greater than, less than, and so on and so forth. So the inevitable happened. Computers moved on from using only 7 bits to 8 bits. So instead of stopping at B7, we went up to B8, and this created another whole column, and 64 times 2 is 128. So this means that we can now represent not only 128, but 256 different characters. And by simply using this high order bit here, by turning that on. So we had a whole range of characters between 10000000 and 1111111111. And as you can see, the absolute chaos which followed is quite unbelievable, because all sorts of people were trying to create different standards that benefited them to utilize this extra 128 characters that you could actually produce now in an extended ASCII character set. IBM devised what is called an EBCDIC-based code for its mainframes, and you can see that there's just loads and loads of different code pages, and these code pages determine how those the different tables determining how on earth you would actually interpret the non-standard ASCII character sets. So not the 7-bit standard ASCII character set, but how would you interpret the 8-bit ASCII character set? So what did the codes with values above 128 actually mean? And not only did IBM get in it, Microsoft, which then had a disk operating system, it's a DOS operating system, it defined different character sets. You can see just hundreds of them, and it created different ones for different areas of the world. So these were standardized as long as you were working within the correct character set, within the correct code page. But if your computer was set up to use the wrong code page, then obviously you wouldn't interpret the data correctly, and it's carried on right into Windows, and it's basically just was an absolute mess with no sort of standardization happening between anybody around the world. So within certain consortiums you'd have standardized codes, but nothing that would be universally accepted as being a system. So to summarize, the extended ASCII character set uses 8 bits, and this allows us to represent 2 to the power of 8 characters, or if you like 256 different characters. The lower set, the first 7 bits, the first 128 characters were part of the standard ASCII character set, were kept, so they weren't changed at all. But the higher order bit characters, so all the characters starting with bit 0, 1, or all the way down, all the way up to the ones with bit 8 turned on, then took on a non-standard definition, and what those characters actually represented and meant was determined by what was called a code page. And depending on what code page you were using, you would then use that to look up your computer, its hardware, and the operating system and the programs you were using would look up to see how to interpret those characters as to how they would be drawn and represented on the screen. So this did allow people to represent different characters, but it didn't create any standardization outside particular blocks. So someone in Israel would have a standardized code set for 128 characters or symbols they want to represent, or Japanese would make use of some of it, and even then it was just a mess because there were 3 or 4 different ways of doing that, and that wasn't even standardized between them. And so you had a case where one encoding mechanism, one code page could not be saved and moved across to another code set on a different Japanese computer, and it just really didn't work as a standard. Right, before continuing, you need to understand the absolute chaos that existed before Unicode. So this is from the Unicode Consortium's website, and says, before Unicode, fundamentally computers just dealt with numbers. They stored they still do. They store letters and other characters assigned to a number to each one. This is what we call a character set. Before Unicode was invented, there were hundreds of different systems called character encodings for assigning these numbers. These early character encodings were limited and could not contain enough characters to cover all the world language systems. Even for a single language like English, no single encoding was adequate for all the letters, punctuation, and technical symbols commonly used. Early character encodings also conflicted with one another. This is very true. That is, 2 encodings could use the same number for different characters. And we've seen how that took place, because with extended ASCII, you could do whatever you wanted with the high order bit encoding. So many different codings could represent different characters depending on the character set the code page you were on, or use different numbers for the same character. Any given computer system, especially servers, would need to support many different encodings. However, when data is passed through different computers and between different encodings, this data runs the risk of being corrupted. So how do we know that we are uniquely going to decode or encode from one character set to another correctly? And that there is the rub. And to this end, this is why Unicode was introduced. Right, the Unicode standard has changed all that. Unicode standard provides a unique number for every character, no matter what platform, device, or application or language. It has been adopted by all modern software providers and now allows data to be transported through many different platforms, devices, and applications without corruption. Support of the Unicode platform forms the foundation for representation of languages and symbols in all major operating systems, search engines, browsers, laptops, smartphones, plus the internet and World Wide Web, with respect to URLs, HTML, and different encodings. Supporting Unicode is the best way